Okay, we're going back to grade 10 for this one. In grade 10, you did this question where you solved a system of two equations. So, do you remember using these words substitution, elimination, or you can graph and intersect the solution? Remember those methods? Maybe? Okay, so solving, they're stacked on top of each other here. We're going to eliminate. Which letter would you like to eliminate? The x's or the y's? I don't think it really matters. Should we go with the y's? Is that okay? Okay, so if I am going to get rid of the y's, I would need to add. Okay, so then 2x plus 2x is 4x. Y's are gone, right? And then 20, so x equals 5. Okay, now what did we do after that? We went back and we did a plug-in. So it doesn't matter which equation, you can do this top one or the bottom one. I'm going to pick the top one. So 2 times 5, plug in. So this is 10. Okay, so that is exactly what you did in grade 10. And then do you remember in grade 11 we did this process, but we did it with 3 equations, 3 variables? Remember we did that? So we're going to do this idea, but we're going to do it with matrices. Okay, so this question I've set up like this. So do you see what I did? The 2 coefficient for x, the y, and the number. Okay, so what I'm going to do is I'm going to try to get rid of that. So I'm going to leave the top line. And then to get rid of that, I'm going to write row 1 minus row 2. So to get rid of that, I'm going to do minus row 1 minus row 2. So row 1 minus row 2 makes a 0. Row 1 minus row 2, so be careful there, you're minusing a negative 3. So then that makes a 6. And then 16 minus 4 is 12. Okay, so this is called row reduction. And now I can just go 6y equals 12. Therefore, y equals 2. And then I plug in. So I'm going to go 2x plus 3y replaced with a 2 equals 16. You can see that we get the same way. Okay, so that's called row reduction. Okay, so let's try this one using a matrix. So if you set it up, it should read 3, 7, 35, 2, negative 5, and 4. Okay, so I'd like to get rid of that one. How do I get rid of that? Because I can't just do 3 plus 2 or 3 minus 2. That's not going to work. Do you remember what to do in that case? I want to make a 0 there. I want to make a 0 there. What would I have to do to make a 0? I'm going to do 2 row 1s minus 3 row 2s. Does that make sense to you, what I did? Because if I times this by 2, it's 6. And if I times this by 3, it's 6. And then I minus them and they're gone. Okay, can you do this number in your head or your calculator, whatever you need? 2 of these, which is 14, minus 3 of those, I'm getting 29. Is that good? Is that what I got? Okay, 2 of those, so I'm at 70 minus 3 of those, 12, makes 58. Okay, so 29y equals 58. Okay, everybody can see kind of the columns. These are always the x, these are the y's, these are the numbers. So 29y equals that number. So y equals 2. And then I go back and plug it in. So 3x plus 7, plug in 2, equals 35. Okay, so what do you think we're going to do? We're going to amp it up a notch. So 3 equations, 3 variables. Okay, so let's start with our matrix here. So 1, 1, 1, 9. 3, negative 1, 1, 11. Okay, so row reduction we're going to do. Row reduction looks like this. This equation needs to start with a 0 in the middle, and then this one needs to start with a 0, 0. Okay, so we added 1 layer onto what we just did. Before we just had the 1, 0, but now we need a 0 and a 0, 0. Okay, so that's our goal. Okay, ready? I'm going to attack that number. Okay, so I'm going to just quickly rewrite my top and my bottom because they're not moving right now. I need to get rid of that. So I'm going to do this. 3 row 1s minus row 2. Does that make sense? Why I picked that? 3 row 1s minus row 2 would make a 0 there. Okay, here we go. 3 subtract the negative 1, so there'd be a 4 there now. 3 subtract 1 is a 2. 3 times 9, so I'm at 27 subtract 11. 16. Okay, now we're going to attack this one. So I'm going to rewrite row 1, rewrite the row 2. So there's a lot of work on your paper, but a lot of it's just rewriting, because that's all just rewriting. Okay, think of a way to get rid of that. Do you have a way to get rid of that 2? Did you pick 2 row 1s minus row 3? 2 row 1s minus row 3. Okay, so 2 minus 2, so there's my 0, that's what I wanted. Okay, so this would be 2 minus 3, so -1. 2 minus a -5 adds the 5, so 7. 2 of these is 18, minus 7 is 11. Okay, next and last, we're going to attack that number. I need a 0 in that spot. Okay, so copy the first 2 rows because those aren't going to change right now, but the 3rd row is. Okay, how do I attack this number? Okay, here's something that you might think to do but is wrong. I actually can't put it with row 1. Okay, here's why. If I put row 1 and 3 together, guess what's going to happen? This 0 is going to become something else, which is just throwing away all the work I just did. So I have to put row 2 and 3 together at this stage. Okay, so what do you want to do here? I would say row 2 plus 4 of these. Row 2 plus 4 row 3. Because then at least my first 0 stays as 0 now, right? If you had done it with row 1, you would have reversed the 0 you just had made. Okay, so row 2 plus 4 of that gets me my 0 in the second spot. So this would be 2 plus 28 then. So 2 plus 28, so I'm at 30. And this would be 16 plus 44. Is that 60? Okay, we did it. We got to the row reduction. That's what we wanted. We wanted 0, 0, 0. Okay, so now we're good. Ready? The last 30z equals 60. Because remember my chart? The first column is x's, then y's, then z's, then numbers. So 30z equals 60. So z equals 2. Okay, move your way up the page. 4y plus 2 plug in z equals 16. And then the last plug-in, 1x plus a y plug-in plus a z plug-in equals 9. Okay, so this one is called row reduction. so I like this method at the bottom here. It shows you I need a 0, 0, 0. Okay, we're going to go further. Okay, we're going to go further, and I'm going to show you what's called the Gauss-Jordan method. Okay, so you can see how I have my 0, 0, 0, but then I continue and make zeros. So this is going to end up like this. 1x equals a number, 1y equals a number, and 1z equals a number. So here's the order you have to go in. I call it a horseshoe. So we're going to do this, 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 which we just did. And then we got to get a 0 there, there, and there yet. And also with this one, we're going to have to work on getting 1s. Okay. So this one again is going to get a little bit longer. So 1, 1, 1, 7, set it up. Okay, here we go. There's my first attack. So again, I'm just going to do a copy. Copy the first, copy the last. Okay, how do I get rid of that one? What do you want to do? I think row 1 minus row 2. Would that be good? Okay, so the top minus the middle line. Okay, our numbers are good. -2, -3, -16. Okay, now we're going to attack that 3. That's the next in the horseshoe. So I'm going to copy the top 2 lines now. Okay, how am I going to get rid of this 3? I'm going to do 3 row 1s minus row 3. Okay, so 3 minus 3. 3 minus -1 ends up being 4. 3 minus 2. So 3 times 7, so I got a 21 minus 9. Okay, next in the horseshoe is that number. We got to attack that one. So again, I'm going to copy the top 2 lines. Copy the top 2 lines, and then we got to figure out how to attack the 4. Okay, so this is the case where you have to think about, can I put it with line 1 or line 2? So you can't put it with row 1 because, again, if you put this with that, your 0 is going to disappear. So you have to do something with row 2. So I'm going to do this doubled and then add it together. So then I still leave my starting 0. So this would be now -4 plus 4. So there's my 0 that I want. All right, so the math on the last 2. -6 plus 1. -32 plus 12. No? So, okay, what did I do? I got some faces.
Yeah, negative 20.
Negative 20. Okay, I'm just going to peek quickly. This horseshoe. Okay, so this check, we did this 0, this 0, this 0. Actually, the next thing is that we need to 1 that out. This needs to become a 1 next. And then we'll go to that 0 in the horseshoe. Okay, so I need to copy the first 2 lines. Okay, I need to make this a 1. So I would do row 3 divided by negative 5. So 0, 0, 1, and then a 4. Okay, and you can peek back to that page about before and see how is our kind of horseshoe pattern going. Okay, the next in the horseshoe is that to be zeroed out. Okay, so that means to copy the first and the last. Okay, this second row, are we going to be putting it together with the first row or the last row according to our zeros that we already have worked so hard to get? We're going to need to put it with the last row because if we put it with the first row, something's going to happen to that 0 and I don't want it to. So if I put it with the last one, there's nothing that can happen to my 0 here. Okay, what do you want to do with the last row then? I think I'm going to do row 2 plus 3 of those. Row 2 plus 3 of those. Okay, so row 2 plus 3 of those still keeps my 0. Okay, if any time you've had a 0 and now it's not a 0, you're doing the wrong lines together. Okay, so 2 of those, so negative 4 plus 0. No, what am I doing? Not 2 of those. Just that, just negative 2. Sorry. That plus 3 of those, that makes a 0 again. Okay, let's see here. Negative 16 plus 12 is negative 4. Okay, the next, I need a 1. So we did a 0, 0, 0, 1, 0, 1. So I need to 1 that out. So what do you want to do to make a 1 there? Row 2 divided by negative 2. So 0, 1, 0, 2. Okay, horseshoe. So we have a 0, 0, 0. So this is the next 0 in our horseshoe. So we need to 0 that out. Which line do you have to put it with to 0 it out? The third, right? So copying the bottom 2 rows because we're actually done with the bottoms. Completely done with the bottoms. Okay, I'm going to do this. Row 1 minus row 3. So 1 minus 0 is 1, 1 minus 0 is 1, 1 minus 1 is 0, 7 minus 4 is 3. Okay, we have our horseshoe, horseshoe, horseshoe. That means my last attack on that one. So again, I'm just copying the bottom rows right now. How do you attack that one? You're going to have to put those together right there. So row 1 minus row 2. Okay, so that makes 1 minus 0, 1. 1 minus 1 is 0. 0 minus 0. 3 minus 2 is 1. We're done. X equals 1. Y equals 2. Z equals 4. That's your solution. Okay, so yeah, do you like my map out of like the horseshoe? This is how you attack the zeros, right? 0, 0, that's the 0 order. But we went like this, we did 0, 0, 0, and then we did a 1. And then we did the next 0, then we 1'd that out, and then we did a 0, 0, and then you would technically 1 that out, but it was already a 1. So that's the order I went. 0, 0, 0, 1 it out, 0, 1 it out, 0, 0, 1 it out. Okay? Does that kind of make sense?